So far in this Chapter 3, Simple Resistive Currents, we've covered a lot of intense circuit problems with lots of resistors, voltages, and current flowing through our entire circuit. Now in this video, we're going to be going back to the basics where we look at resistor in series and resistor in parallel and look at the actual fundamentals and formula that we can use for any problem. And in fact, there will be linked below more complex problems that are going to take place after this, where we put this basic knowledge into a bigger circuit diagram and try to add everything together and try to add all of our resistors together. So that should be fun. Also, if you want to see the other videos that we did in this chapter, again, that are way more intense than this, because this is just the fundamentals, that will also be in a playlist link below. So let's get right into it. We have these resistors in series, and the formula for resistors in series, again, this is if a resistor is right next to another resistor that's right next to another resistor, and it can look like this or it can look like this. This is a more complex diagram, but this is in series with this. And then these two are in series with this, and all those three are in series with this. All those four are still in series with this. So again, they all just add up together. All of the resistance adds together because the current flowing through this entire line is going to have to go through all of those resistors. So the formula for this is going to be the summation. Since we have multiple resistors that we're adding together, we are starting at 1, so we're going to have I is equal to 1, and we are running this for K is equal to N many resistors. We're just going to have R subscript I because we're adding resistor 1 and then resistor 2 and then resistor 3, and this is equal, I'll actually put this on this side, this is equal to the equivalent, or it's also written as R total or RT. For this specific problem, we are going to have that our R total, or we can also write it as R equivalent, I'm going to do it like that, is equal to our R1 plus our R2 plus our R3. Again, if we had more, we would just keep adding them, and now we can fill in these numbers. We know our R1 to be 29,466 ohms. We're going to add this to our 450,479 ohms, and lastly, we are going to add in our 3,569 ohms. If we do this, we're going to see that it is equivalent to 483,514 ohms. And this is the answer for our first part. Now that we have done resistors in series, we're going to tackle resistor in parallel. For this, we're going to have something similar to our equation that we did for resistor in series, but slightly different. So we need to have, instead of R total, we're going to have 1 over R total. This can also be written as 1 over R equivalent, and I'm going to write it like that just to show that it can be. So we have 1 over R equivalent, and this is going to be equal to the summation of N. This is the number of resistors that we have. Starting at I is equal to 1, and then we have our expression, which is just 1 divided by Ri. Now that we have this, we can plug in the values for this problem. In this specific problem, we have 1 over R equivalent, and that is equal to 1 divided by our R1 plus R1 divided by R2 plus R1 divided by R3. I like to rewrite this into a simpler way, so we can rewrite this formula, and the equivalent to this formula would be that R equivalent or equals is equal, and then we will have parentheses around everything, 1 over R1 plus 1 over R2 plus 1 over R3. The only difference is that we are going to have this raised to the power of -1 because we are moving this from our R equivalent side. Now that we have this, we can just plug in our values. So I'm going to have our parentheses like this, and then inside of our parentheses, I'm going to have our 1 divided by our first resistor, which is 103,770, plus 1 divided by our second resistor, which is 407,114, 239 plus our third resistor. Again, if we had more resistors, we would just keep going on. 1 divided by 2,636. Then this is all going to be raised to the negative first power. If we do this, we are going to get the answer 2,554.5725. And this is our answer. So that's the difference between series and parallel resistors when we are adding resistance. I hope you found this video helpful. Again, if you want more advanced examples of this, they're going to be the top link in the description. If you want problems that have this in it, it'll be in a playlist, second set of links in the description. If you want the notes for this and this chapter, as well as the other chapters for Introduction to Circuits, that will be the last link. And if you found this video helpful, consider giving it a like and subscribing for more content just like this, and good luck on your studies. So far in this chapter 3, wait, what is this chapter 3 even called? Oh, this chapter is called Simple Resistive Circuits. Okay.